Identify all the stereocenters of LSD. In addition to that, identify the stereochemical configuration. So, to first identify stereocenters, you have to look for um, the chiral molecules, chiral carbons, which are sp3 hybridized within this particular molecule. So, an easy way to do that is just look for places where there are 4 bonds that form. And this one right here is a stereocenter. In particular, it is bonded to a different carbon. It's bonded to this ketone group right here, or technically an amide group. It's bonded to an amide group in addition to a carbon right here that's bonded to a nitrogen, and then a carbon double bonded to another carbon down here. Now this is a chiral center because its 4 substituents are all different, and that is a important marker of stereocenters. To find other ones, I would say this one in particular is another one. This is sp3 hybridized. It's bonded to a nitrogen, hydrogen, another carbon, and then a carbon over here. Now you might wonder, how is it a chiral stereocenter if it's bonded to 2 carbons? Well, you have to keep going down the path, and I mean not the path in the sense of what else is bonded within this molecule. So you have 2 carbons right here, and then it offshoots, right? It offshoots here, and then there's a double bond here, and it offshoots here, connects here, makes a double bond here, and then this is primarily where it changes in terms of its substituents. This carbon right here on the bottom right has another carbon, um, 3 carbons down, that is bonded to a amine group, and that differs from the carbon over here, which is connected with a benzene ring. So that is another stereocenter. Now, are there any others present within this molecule? We can start looking at other places and just crossing it off. That's another good way to go about this. So no carbon here is a proper stereocenter. There are not 4 substituents or 4 bonds, or rather 4 different unique substituents. This is not sp3 hybridized. This has only 3 unique substituents. Nitrogen can be considered a stereocenter. However, it is advisable not to consider it one due to the fact that it does differ in terms of its configuration. It can either be an S or an R configuration um, within a moment's notice. Even if you do recognize it as an S configuration or an R configuration, it switches in between that instantaneously within a molecule. So it is not useful in naming primarily any other molecule other than carbon as a stereocenter. So we can keep looking down here, and it truly looks like there are no other stereocenters in this molecule. So we did that first part correctly.